So very quickly, Xenon, based in Melbourne. We have people also in New South Wales and Queensland. Myself, I'm in Gold Coast. So I've come here to enjoy the sunny weather that Christchurch offers. I'm originally from Gisborne, so I'm just giving a bit of stick because I'm from the North Island, not because I'm from Gold Coast. So over 25 years we've been dealing with the HPC industry in Australia. A few of our projects there, and at the top there you can see why Peter was interested in Pawsey, dealing with them and supporting them. So a quick intro into what this talk's about. There's been a bit of interest around the HPC and AI convergence the past couple of years. So having been with Xenon 18 months, sitting in the different conferences, I'm coming from an industry background, seeing some of the different conversations and questions. So I just thought I would try to help demystify some of the things around container workloads, where the automation approaches across DevOps, MLOps, how they may help and where some of those things may be helpful. The information that I'm putting forward, really for you to pick and choose. It's not prescriptive to say this is how you should do it. And where Kubernetes can kind of step in and help support some of those automation approaches and workflows. Can you lift and shift HPC style jobs onto Kubernetes? I'm ignoring microservices for this talk. It's not what we're here for. And storage access. And lastly, whether or not there's any hybrid architecture with cloud on-prem and IoT. So where IoT, probably lab devices, things like that. This one here is just really a quick one to say there's a buzzword explosion in the sort of automation space. So XOps is what I refer to it as. I've tried to put a little chart together to show where I think things have flown and where things have come from over the years. The important part here is don't learn all of it. I tend to just refer to everything as DevOps. And if I talk to somebody else and they say, oh, well, I do MLOps, well, then I start using MLOps terminology. So if you want to come and have a talk to me later on and one of these things clicks with you, then feel free to have a chat around that. And if I say DevOps, I mean everything on that screen. So there's been a bit of an evolution of automation. So I've been involved with this type of field probably for about 8 years now. And prior to Xenon, I was in the mining industry. And back then there was DevOps and Kubernetes was starting to be spoken about, and do we use containers? And along the way, SRE, Site Reliability Engineering, out of Google came along, and people were like, what's the difference? Is it new? Do we need to take this on? And then platform engineering's kind of taken off in the last 2, 3, 4 years in America and starting to get into Australian vernacular. I'm not sure if it's in New Zealand yet. But I just thought I'd just say there's a bit of a definition, the way that I think about it. There's a lot of overlap, but the DevOps at the start's really around culture, establishing your team, what's important to us, how do we want to work. The SRE, I see that more as an operating model that wraps around DevOps as your tools and process flows. And then platform engineering is taking both of those again and saying, well, how do we do that, but in a self-service model? So that's basically how I boil those three concepts down and try to demystify that automation. At the bottom, DevOps, that's where the dev and the ops, you build it, we run it, if I'm an ops guy. The SRE is more when you're combining your team and your operating model and there's shared responsibility, right? So we build it, we run it. If we break it, we buy it type thing. And platform engineering doing the self-services. I'm an ops guy, I'm hiding down like an iceberg under the water, you don't see me. You do what you want up the top and deliver what you need to. This one's really just to say around the hype cycle for those types of concepts where they are. This is taken from late 2023. They're generally, all of those concepts raised, Gartner was saying in about 2 to 5 years they'd be mature. And that's over there to the far right of the curve. From my perspective, all of those things are already sitting over where number one is. They're already there. There's lots of material out there, lots of ways to do it, lots of patterns defined. And really it's not a case of I need to go and try and figure something out or reinvent the wheel. There's plenty there to use it. So use sort of all four of the DevSecOps, SRE, platform engineering, GitOps to help your automation start. You don't have to go all the way down the rabbit hole and do everything. Pick and choose the parts that make sense from any container approaches. So I just want to focus here on platform engineering, why it's important. Now this was taken from a paper from NIPS back in 2015, I think, that Google presented. And the ML code in the middle there, AI code people would talk about now, is kind of a tiny part of the whole system. So the production aspects are really everything else. And all of those production aspects, we want to automate it, we want to scale, and we want to make sure that there's security, etc. And delivering all of that in a timely fashion is probably the biggest issue that we had, and we found that taking container approaches really sped that approach up. So the paper, if you want to look it up and find out about it, Hidden Technical Debt for Machine Learning Systems, a very good paper. Anyone who's going down platform engineering for AI, ML ops, data science should give that paper a read and have a look. This is a little bit of info from the experience that I've had around how we set up the platform. I said I wouldn't talk about microservices, and I won't, but the 12-factor app comes from that sort of world where I want to spin up an app quickly and how do I manage it with a container. The really important one there is really configuration as code. Manage it like you would code, put it in the repository next to it, secrets and keys, pull them out, but have a way to inject them. Semantic versioning allows really rapid approaches, DevOps, blue-green deployments, GitOps approaches. And the Open Container Initiative is, so OCI, is really where Docker files have been handed over and they're known as the OCI interface, and that's the standard. And Singularity can build OCI compliant images. So if at some point you want to build Singularity images and think, can I lift and shift in the future, you should be looking at making them OCI compliant now. And then that way, no matter what container engine you're going to run it on top of, the lift and shift enablement should be more seamless. I'm not going to sit here and promise that it'll be pain-free. I haven't done a Singularity conversion from that to Kubernetes, so I'm not going to go and promise anything on that one. So an AI platform, I just want to sort of give a concrete representation over that sort of abstract little pieces I've just given. When we were speaking to internal customers in the industry, we would talk about an above-the-line deployment versus a below-the-line deployment. And below the line, as an ops team and a platform team, that's what we take care of. And we present templates and options to our customers for self-service, and that's an above-the-line deployment. And really, you can pick and choose any of these components. Which ones do we want? Which ones provide what we need to? Some examples are given there, and in case of information overload, I'll move on, just so we're not trying to dig into the little itty-bitty things there. So instead of trying to build that iceberg all on your own and select the components, a shortcut to it is going with platform as a service solutions. So there's two options here that we are quite fond of at Xenon. So RAFI's on the left there. In our dealings with NVIDIA cloud providers who need to try and provide GPUs as a service and rent and have those single GPUs, RAFI is really good. It goes all the way down across the infrastructure layer as well and really provides a cloud sort of approach, can be white labeled. Run AI, who some may have heard of if you're in the AI world, that's been recently bought by NVIDIA and open source. You can think of that as an ML ops platform, whereas RAFI is more sort of stack complete right across everything there. Second option for some platforms as a service, Kubeflow, completely open source. Again, another ML ops platform. And NVIDIA AI Enterprise, where you can have your AI support going with it. And I'm just flicking through these quickly. I'm just trying to provide some seeds and information where you might go through. Plugging some of these things together, I'll introduce down the bottom left there, Netris, which can do your software-defined management of your network so that you can have hard multi-tenancy, making sure that any traffic going through those switches, etc., are only for those types of customers. You may have regulations even in research where certain data can only be accessed and moved through certain hardware. And the RAFI one that I introduced before, up the top left there, is really managing a whole bunch of other open source projects under the covers, and they're on the right. So KubeOVN introduces subnets into the Kubernetes world, because Kubernetes doesn't generally have that. You can extend it. KubeVirt allows you to run VMs in containers on Kubernetes. And vCluster is allowing another form of soft tenancy. So you may have a cluster for inference workloads, and that's linked to certain node types. Another one for interactive workloads, and that's linked to other node types, which will allow you to pick and choose what type of GPUs and the cost that you want to expose to those types of users. And you can combine them all and you can get hard multi-tenancy and soft multi-tenancy together. Another example of what's on Kubernetes is kube apps. So open on demand, I think, is the equivalent, HPC world. Put that on your template for your platform. When you spin up a V cluster, for example, kube apps could be exposed to users. There you can have a tenant admin who can pick and choose. I want to put a MySQL database up for my users within my tenancy. You can also provide a catalog that you curate yourself. So you say we only want to allow these types of apps to be exposed to users. What's shown there is what's known as the Bitnami catalog. That's VMware. They provide all of those things into there, manage it. So can we do batch scheduling on Kubernetes? Because it's a microservice one, right, like historically. So Apache Unicorn on the left there is one of the ones that I've looked at quite extensively, and I would say it's feature complete as far as workload management, scheduling, gang scheduling, fair resource use, hierarchical queues, RBAC, user access. And that one there, essentially, it pulls out the Kubernetes scheduler and puts that in place, and it can run everything. It can deal with whether you're running microservices or batch schedules on top of it. It was originally designed to support Apache Spark workflows on top of Kubernetes, and they have committers such as from IBM and NVIDIA working on that one. We jump to the far right there, SCEDMD's managing a project called Slinky now, which allows you to manage Slurm from on top of Kubernetes. They have a second project they haven't quite released, which will do the unified resource scheduling similar to what Unicorn does. So with the two projects, you'll be able to do everything on Kubernetes using Slurm. The two in the middle I've just put there just for information, just in case you come across it. They are used. They integrate with Kubeflow, which I mentioned earlier. My favourite's Unicorn out of those ones. So with Unicorn and the Kubeflow operator, you can run MPI jobs on Kubernetes in containers, PyTorch, TensorFlow, Ray clusters, yada, yada, yada. The next one that I want to talk about here is Cilium. So Cilium is a container networking interface. So when you stand up a Kubernetes cluster, you need to choose what your network interface is going to be. So you've got to say, we're going to use this network interface for all of our pods and containers to talk to one another. Now, by putting Cilium on, what you can actually do is you can have cluster meshes, so you can have the same unified network policy across multiple clusters. So you could have a Kubernetes cluster in Auckland, one in Christchurch, one in Wellington, unified network policies going across it, so you could allow for geo-failure, fault tolerance, and all those types of things. Another example with it is shared services, so separating out onto clusters, putting, say, storage onto one cluster and managing that, so any stateful services are a good idea to have on one cluster, and stateless services, such as inferencing services on another cluster. There's some headaches involved in managing those things, going through any deployments, whether it's blue-green or you're just going on a big bang approach. I tend to like that shared service approach for pulling the storage aspects out, shared values, keys, etc. That's the network policy enforcement I just mentioned, just to show how it can do it. IoT Edge gateways, so Kube Edge. This is a good one for synchronization back to another central Kubernetes cluster. So you might have a server up in the hills for some reason, and it can communicate back to a central cluster. K3s is built for going on devices. You can do production-grade clusters with it, but the K3s one could be on a device gathering sensor telemetry data, communicating back to your Kube Edge gateway, which provides security, etc., with that going back into your central cluster. And both of these actually integrate with Cilium as well. So again, that uniform network policy, shared services. You could have something on K3s on a sensor, a Raspberry Pi running somewhere, and you're still accessing the same storage interface that you would on a central cluster, with your edge gateway managing the synchronization if the network goes down. To talk about storage very quickly, a lot of the vendors have their own what they call a container storage interface, a CSI. So if you have these types of technologies, you can take their CSI, put it onto Kubernetes, and you now can start managing all your native functions from Kubernetes. And that allows for things like dynamic volume management would probably be the primary requirement. There are other general drivers around NFS and SMB, and that allows you to put those storage volumes into a container and expose it. And the cloud hyperscalers have all their own versions, so S3, blob storage, etc. So here I just want to cover off a real quick, simple adoption idea. If you're kind of on the fence around, do we use Kubernetes? How do we go about it? What's a really good, quick approach? So breaking it down, do a POC just to prove the technology. Can you run a batch job in a container on Kubernetes? And can you do it quickly and easily and cheap? So with the NVIDIA GPU operator and the Kubeflow operator, you could put that on a single Kubernetes cluster, on a single node cluster, single machine, and you could test that out yourself. So no VMs, that introduces a bit of complexity. You can use VMs and share the GPU through the VM layer and then through into the Kubernetes and then into the container, but for a POC, it's kind of pointless adding in that type of complexity. Once you have the GPU operator and the Kubeflow operator triggering a job, you can then introduce the NVIDIA network operator and start testing any GPU storage directs things. RDMA, so that's allowing your GPUs from one container to the other to talk to another directly. Once you've got through the POC stage and you go, yes, this actually looks like something we could use, you could then introduce an MVP, minimum viable product. And here you'd be proving out the scheduling workflows. Can we get the same usage that we can from PBS Pro, Slurm, etc., around things like our scheduling and our queues? And you may want to then start extending the training operator. Can we run more than MPI jobs, some of the PyTorch LLM jobs perhaps, TensorFlow, and you're using the GPU and network operator again, all on a single machine, single node cluster. From there, once you've proven it out, then you can start looking around, you scale out, how do we do this properly, and you start taking in all of your production considerations. Here's some other tips, very sort of shotgun blast, I appreciate that, and probably not easy to read there. Number one, the leaky tap strategy comes from DevOps, and that's really around what are our future versus past consideration. The leaky tap strategy says if you've got water on the floor, don't mop it up now, go and turn the tap off. Deal with the problem now, worry about your future considerations, and then when you get time and safety, mop up what you can as you go along. So with that there, with the leaky tap one, you could say for our containers, and we're not sure how we want to use it, so you can start doing very simple DevOps pipelines where the DevOps pipeline would build your images for your researchers. So you take that sort of cognitive load off the researchers, put that onto your platform team. By doing that there, you're saying these are our future considerations, adding in things such as templates and blueprints, deployment stamps, maybe new phrases I'm throwing at you here, but they're all designed to help with that leaky tap strategy. Scaffold repos, we refer to them as scaffolds, not instead of template repos, because they're functional. So if you do a git clone and pull it down within 30 seconds, whatever, you can run it. That's your hello world, basically, of the Kubernetes land. By providing the scaffold repos to researchers, you're already giving them a way to interact with DevOps pipelines if you go down that route. If you decide not to, you can still implement security controls and things like that into the scaffold repos directly. Virtual clusters, very good, I like them, use them. GitOps approaches make it easier for doing complex deployments. So if you want to go down the route of interactive clusters, and do we stand up a new interactive cluster when we want to add a new software to our interactive cluster blueprint, how do we manage that? And the answer is through GitOps and B clusters, stand up the other one, allow a certain small group of users to jump on there and do your UAT, and when you're happy, tear the other one down, pull the load over to the new one. Plenty of reference architectures out there around what I've spoken. The Azure MLOps v2, very specific I know, but that's what they call it. There's a very good reference architecture for everything that I've spoken about today. You can take what they have, put it on-prem, you just got to change it out. So instead of using Azure blob storage, you say I use object storage on-prem. Instead of using Azure Kubernetes service, I'm just using vanilla Kubernetes or whatever flavor that you choose. AWS have their own as well. NVIDIA have plenty of reference architectures, and as luck would have it, we also have our one called the AI Sandpit, which happens to tie back into the single node things that I was talking about as well. And if you want to connect with us, there's a QR code. Very quick, I hope didn't overwhelm with too many phrases and terms there, but yeah, that's it.
Thank you, Adrian. Right, any questions? Yeah, thanks.
Hello
Thanks,
again.
great talk. Does this actually work? Because
I don't think so.
yeah, okay, I'll just pretend. Okay. So what I'm really interested in is the future of how to do high performance computing. Thinking of the ML world that you just spoke about with Kubernetes and batch mode processing, containers, and these kind of things, versus the more traditional simulation world where people use MPI with Slurm. You mentioned Slurm before, and so forth. And I think in the future a lot of compute centers will want to join up these things as much as possible.
Unify,
so I'm wondering which side will come together and how, so how do these things come together? Because I think Kubernetes, and I don't have a full understanding of it, but I think it is not really designed to run very large-scale, high-performance computing applications, right? So it's more geared towards microservices, batch, these kind of things. So do you have a comment on that? So where you see this coming together?
I've got lots of opinions on that one. I'll try to keep it brief. Short answer, I think the AI workflows are going to win in the long run. You've got Meta, Facebook, Google, Microsoft. They're all going down this path, and they're purchasing 300,000, 200,000 GPUs at a time. They want to get as much usage out of it as possible. Banks, of course, they're all in on it as well. Industry like mining, oil and gas, they're all looking at these things as well. So I think to break it down, though, we need to look at three different distinct workloads too. So inferencing as a workload, it's pretty distinct. There's still microservices involved there. Production style access, user controls, web-based access, API access. The second one is, the training clusters. So we hear a bit about pre-training these days, and they're very large. Most people don't need to do that. You don't need to go and be Elon Musk and stand up 100,000 nodes and start doing pre-training, right? You're more likely going to be using training clusters for things that have passed through the third one, which is your interactive mode, where you're going through Jupyter notebooks. I've figured out something. I've done a couple of little runs on sample data. I like these experiments. Now I want to maybe put on, in machine learning terms, put it on and do a hyperparameter tuning job, right? So the three distinct workloads are very different. And I think the biggest one is going to be, how do you manage your GPUs effectively, get that highest resource utilization out of it? And how do you get these AI and ML researchers who say, hey, I want that GPU now, and how do you get them to fit in with other users from the HPC world who are used to running jobs by putting it in a queue and waiting for it? So the reason that I've put things like Rafi and Run AI up before is because their sort of point of difference is around managing those GPUs as a service. And so on an interactive cluster, you could present those GPUs as a service, and people can do time slicing. What's the other one? There's the MIG that NVIDIA do. So all of those functions that the GPUs have are surfaced up, both to the operator, and the operator can choose, platform operator, can choose what to expose to the users as well. And with respect to batch workloads, and it's not made for it, I would say that's kind of that's old news. I would say that's firmly no now. It is for batch workloads. There's no reason why it can't be used purely for batch loads. It's come a long way in the sense that I now look at Kubernetes as a data center operating system. So you have your raw networks and storage and infrastructure, and you put Kubernetes on top. If you really want VMs, then I would put a VM on top of Kubernetes and manage it that way as well. And then if you wanted Kubernetes on a VM on Kubernetes, you could do that too, but kind of pointless. But I do think that Kubernetes is going to be pushed onto people more and more, I'd say, in this realm, and there'll probably be a bit of pushback around workflows and culture, as where I've seen in the past around establishing ML ops platform even in industry. So I want my file system, and I want to be able to access my data and do my things my way. And there was a big culture shift required around, you have a role, you're a developer, you're not Adrian Torrie, and as a developer for our organisation, you are delivering value in this fashion, so your role will define what you have access to. So those kind of worlds, there will be a bit of a collision. I think in the storage aspect will be the one that will hold it up. Not the compute, not the networking. I hope that answered the question.
Yes, but maybe I'll talk to you later.
Yeah, okay.
You guys can meet up at dinner.
Yeah.
Kahu, last question.
Okay.
If you still want to ask.
Yeah, I suppose. It might be loud enough, I guess. So probably more of a lower level question about the management of the life cycle of Kubernetes itself.
About the what, sorry?
The management lifecycle of Kubernetes itself.
Yep.
Each version is only roughly 6 months.
Yeah.
So what do you guys use, or the suggestion in regards to the management of that lifecycle? Like
So-
updating the nodes to keep them up. If you don't want to fall behind, especially
Yep.
or unworkable clusters to grow, there's also those that you need to keep bringing up to them that like later versions of things.
Yeah, so we use Ansible at the low level,
Yep.
and having that sort of that API skew is what you're talking about, right? So having your kubectl and your Kubernetes versions in line, which is why when I say talk about production aspects, production considerations, you should always be going in with high availability Kubernetes clusters, and by that I mean at least 3 control plane nodes. So people going in with 1, no, don't do that, bad idea. Don't go in with 2 because you don't get any quorum from it anyway, so always plan for 3. The next step would be 5, but you'd only go to 5 if you need scaling, right? But I would be vertically scaling my 3 nodes before I'd worry about horizontal scaling to 5. But for the version skew, you'd be taking down just 1 control node at a time, performing its updates, reattaching it back to the cluster, next one. So you're just doing your rolling updates. So that's a long-lived cluster, right? And a long-lived cluster would be where you're doing your interactive workloads. So you want to have, and you may have an SLA, you might have 5 nines, whatever.
Yeah.
So where you've got those SLAs and you've got users accessing it, rolling updates would be the one. Something like a training cluster, I'd just tear it down and put it back up. Yeah. So you've got to differentiate the workloads. Sorry, I can't just give one answer in this game. This is the way, mate.
Sounds like another dinner conversation. Perhaps.
Yeah, happy to chat more. Yeah, we've got lots of ideas about these things.
Yeah.
And as you can tell, I've got lots of opinions about it too.
Shall we all do that?
Yeah.